This lesson is about solving quadratics by undoing. Before we actually talk about how we are going to solve on quadratics by undoing, I want to take a second and talk about what it means to solve a quadratic and what it is that you're looking for when you solve a quadratic. So remember, quadratics look like this. They say ax squared plus bx plus c. And when we solve a quadratic, they can have one, two, or no answers at all. And there's a reason you can have a varying number of answers. You can have a varying number of answers because what you're looking for when you solve a quadratic is you're looking for a specific point on the graph. You're looking for the place on the graph where it intersects the y-axis. So the answers are where the parabola, which is that U shape that a quadratic makes, intersects, my paper's sliding around there, intersects the x-axis. So depending on where your parabola is on the graph, so here you've got a graph. If your parabola is out here and never touches the x-axis, then there's going to be 0 answers to that because it never intersects the x-axis. If you have a graph and your parabola touches like right at the vertex, that's going to have 1 answer. So there's 0 answers here, there's 1 answer here. And if you have a parabola that does like this, you're going to get 2 answers because we don't touch the x-axis at all. We touch the x-axis in 1 spot. Here we touch the x-axis in 2 spots. So that's what we're going to be looking for. We're going to take the actual functions and we're going to solve them to see where it is that they cross the x-axis because we can't easily graph every quadratic function. This is a quadratic function that would be hard to graph and find where it is. So what we're going to do is we're going to use something called the square root principle. Let's take a second and talk about that. You've used the square root principle to an extent. You've solved Pythagorean theorem problems. But when you solve Pythagorean theorem problems, you can't ever use the other half. So the square root principle says that there are 2 possible answers to all square roots. There's a positive answer and there's a negative answer. So when you do the Pythagorean theorem, you only use the positive answer because you can't have a length that's negative. But when using the quadratic, when you're solving quadratics, we use the square root principle because you can have a positive answer and a negative answer because the x-axis goes in both directions. And remember, that's what we're looking for. We're looking for where it intersects. So let's use this function right here, this equation, x squared equals negative 144. And we're going to use the square root principle to solve this problem. So what we're going to do is we're going to take the square root of x squared. And when we do that, we're going to write a plus or minus sign in front of this. And we're going to go the square root of negative 144. So the square root of x squared equals a plus or minus. The first thing we have to do when we're dealing with a negative square root is we need to take that negative out. Remember, that negative comes out as an I. So we've got the square root of x squared equals a positive or negative I times the square root of 144. And then I know, and you should know, that the square root of 144 is 12. So the square root of x squared is x. And we get plus or minus. The square root of 144 is 12. There was already an I outside, so it stays with our 12. So where this function would intersect the x-axis is at negative 12i, positive 12i. So when we write this positive and negative, that's telling us, hey, don't forget there are 2 answers there. There's a positive answer and a negative answer. And then we want to actually write our answer out, and we call this set notation. And set notation goes from the least to the greatest. We want to get them in order. And notice, set notation uses brackets, not parentheses. So make sure that you use brackets. And I know you're going to complain about they're hard to make and they don't look good. Give me something that is not parentheses. because parentheses indicate an ordered pair. And this isn't an ordered pair. This is negative 12i on the x-axis, positive 12i on the x-axis. So you have to have brackets because otherwise you're giving me an ordered pair. So let's look at a problem that looks more like the equations that you've been solving since you were in junior high and middle school. So negative 8 plus 2x squared equals 0. So first thing we want to do to solve this problem is we want to isolate x squared. So we're going to solve this problem. We're going to pretend like that's just like an x in any other equation, and we're going to get this isolated by itself. So I'm going to add 8 to both sides. And then that says 2 times x squared, so I'm going to divide by 2. Because remember, when we're solving equations, we do the opposite operation. And we do it to both sides of the problem. So 8 divided by 2 is 4. So now we're to that x squared, and we've got x squared. So we're going to use the square root principle, and we're going to find the square root of x squared and 4 to find our answer. And we're going to write it in set notation. So we do the square root of both of these things. So this becomes the square root of x squared equals plus or minus the square root of 4. The square root of x squared is x. And the square root of 4 is 2. So in set notation, we say negative 2. We use our negative sign. And then we say 2 because we use the positive sign. You can put that positive sign in front of that 2, but it's not necessary. We know that it's a positive 2. Anytime there's not a negative sign in front of it, then it has to be a positive. All right, so let's look at an example where it's written in vertex form. Remember, vertex form looks like this. Vertex form says x plus 10 squared minus 24. And in this case, we're going to make it equal 0. So the x is still being squared, only now the x is inside a set of parentheses that are being squared. So what we're going to do is we're going to isolate that entire thing. So in this case, we're going to isolate the parentheses being squared. So that's what we want to do. We want to take this set of parentheses and we want to isolate that. So to do that, we need to get rid of this positive 24 or this negative 24. So we're going to add 24 to both sides. We're going to be left with x plus 10 squared equals 24. Now, when you're solving, you always do, if you're doing order of operations, you get rid of parentheses and then you get rid of exponents. Well, when we solve an equation, we're doing it backwards. So we need to get rid of the exponent and then worry about the parentheses. So let's get rid of this exponent now. So we're going to do that by taking the square root of x plus 10 squared and use the square root principle, so put your plus and minus sign, the square root of 24. So I'm going to come over here and I'm going to do the square root of 24 because it's not a perfect square. 24 divided by 2 is 12. 12 divided by 2 is 6. 2 divided by 6 is 3. And 3 and 1. So I've got a pair of 2's. I'm running out of space here, so I'm going to have to cram it in here. So I've got x plus 10, because the square root and the squared cancel each other out, equals plus or minus, don't multiply these together, they come outside as a pair, 2 square root of 6. Multiply that 2 and that 6, or that 2 and that 3 that are left over. Multiply those back together. Now we want to isolate the x that we have here. So we're going to subtract 10 from both sides. This is running out of space really badly. So I'm going to come right up here, go up there. We're going to say x equals negative 10 plus or minus 2 square root of 6. You can't actually combine these things. You can't combine these two things together because this doesn't have a house and this does. So when we write this in set notation, I'm going to come down here, cram it in here. I'm going to say negative 10, and I'm going to do the minus 2 square root of 6, because that would be a smaller number. and the positive and the negative 10 plus 2 square root of 6 would be my bigger number. So that would be my set notation. It's a big, ugly number, and if you were to actually type it into your calculator, you would get a number. You would get a decimal, but we don't want the big decimals. We want this because it's a more exact answer. So that's what we're going to go with. I want the most exact answer. I don't want big, long decimals. Let's do a couple more like these because these are the ones you're going to see a lot of. You're going to see a lot of solving things that are in vertex form. So let's go to the back of our page, and we're going to do the same set, the same things. We're going to take something that's in vertex form, x minus 9 squared equals 64. So this is what's being squared, so this is what we want to isolate. It's actually already isolated in this problem. There's nothing being added to the outside. There's nothing being multiplied to the front. So we're just going to do the square root principle. So we're going to say x minus 9 squared equals plus or minus the square root of 64. So the square root, and the square cancel each other out and leave you with x minus 9. And I know that the square root of 64 is 8, so square root of 64 is plus 8 or minus 8. Now, in this case, we're going to set this problem up, and we're going to say x minus 9 equals a negative 8, and x minus 9 equals a positive 8. Because we need to solve this equation twice, because 8 could be a positive, because 8 times 8 is 64. It could be a negative, because negative 8 times negative 8 is 64. So we're going to add 9. So negative 8 plus 9 is 1. We're going to add 9 again. 8 plus 9 is 17. You're going to see that the answers do not have to be opposites. In our first few examples, sorry, paper sliding everywhere. In our first few examples, negative 12, positive 12. Negative 2, positive 2. Negative 10 minus 2 square root of x, negative 10 plus 2 square root of x. Those are all opposites of one another, but you don't have to get opposites. So don't just go, oh, well, if this is 1, then this must be negative 1. You need to actually set up the two equations and solve them independently so that you can find those two places where your graph crosses the x-axis. So 1 and 17 in set notation. Solutions do not have to be opposites. So don't just assume that they will be. Take the time to solve each one.